Hello everyone, and welcome to our 8.4 notes on triangle proportionality. I know that sounds scary, but I promise you it's not. We're going to be working with a whole bunch of proportions today, just like we have been the rest of this unit. Our warm-up question today is, what is your go-to karaoke song? I would have to choose I Want to Dance with Somebody by Whitney Houston. It's just a classic. So let's look at what the triangle proportionality theorem says. Sounds scary, but it's not. This theorem just says that if you have a line, so that in this picture is going to be DE, that is parallel to one side of a triangle, so DE is parallel to AC, and it intersects the other two sides, so intersects means it crosses, so it crosses at point D and it crosses at point E. It intersects the two sides. It divides those sides into segments of proportional lengths, meaning that the way that BD relates to DA is going to be the same ratio as the way that BE relates to EC. So not saying that those pieces are congruent, but they're going to be in the same ratio. So let's fill that in with letters. So if DE is parallel to AC, then we know that the way that BD relates to DA, that ratio, is going to be equal of the ratio of BE over EC. So I'm going to color code that, BD and DA and then EC. So those two would be equal to each other. And so I kind of look at that parallel line as like the fraction bar. I know this is kind of weird, but I look at this line as the fraction bar. And so then you have yellow over orange equals yellow over orange. And I treat those triangles like the equal sign. That just kind of helps me visualize it. So like here's what I mean by that. On here is my equal sign. Here's my parallel line. It's parallel to this third side of the triangle. And so then we have this fraction, yellow over orange, would be equal to this fraction, yellow over orange. So you can kind of turn your head sideways, and it kind of sets up the fraction for you. This triangle proportionality theorem, x over 18 equals 56 over 21. Okay? So that is what allows us to solve. And so what are we solving for? We're solving for the missing piece, which is x. So we're trying to find out how long is x. So you're going to cross multiply. Whenever you solve a proportion, you're going to cross multiply. So y'all have gotten really good at this the last few weeks. You're going to do 18 times 56. And you click enter, you get 1,008, and then you divide that by 21. So whenever you cross multiply, you get x equals 48. 48. I always go back and put that piece in the picture just to make sure it makes sense. 58 over 18 is the same ratio as 56 over 21. Okay, so let's do that again here on our next problem. So do we have that parallel necessary step that's parallel to the third side? Yes. So there's my equal symbol, and we have x over 7. You can kind of turn your head sideways, or you could go 7 over x, either way, equals this yellow piece, which I don't know, so I'm going to have to find it. We're going to come back and find that in a second, over 6. Okay, so I've not learned anything as of yet about using the full length, so I can take that 27 and subtract what I've used so far, which is 6, so that forces this piece to be 21. So even though I didn't know it before, now I know what it is. Okay, so that would be x over 7 equals 21 over 6. So then again, you just cross multiply. 21 times 7 is 147 divided by 6. X is 24.5. 24.5. Okay, let's keep going. Never just assume that this line is parallel. You do need to check every time. If it's not parallel, then the triangle proportionality theorem is not going to hold true. So we want to check for that every single time. So there's my yellow pieces. This gets split the same way that this gets split. So when I set that up, that would be 2/5 should be equal to the way that x relates to x plus 6. Now remember, whenever you have multiple pieces, whenever you're cross multiplying, we want to put that in parentheses. That is going to be a binomial. And so that's going to be 2 pieces. And so when we cross multiply, I'm going to have to distribute. That is going to be 2 times x plus 6 equals 5x. And so you're having to distribute the 2 to both of these pieces. So 2x plus 12 equals 5x. So 12 equals 3x, and x is 4. Let's go back and plug that in and check ourselves before we wreck ourselves. That would be 4 over 4 plus 6, which is 10. 4/10 does simplify to 2/5, so that you know that you did good work there. Okay? I need to fill these in the boxes. 24.5 and 48. Okay? So this one we're looking for x again, but you're going to notice they give you the full piece. So let's first make sure that we have this side that is parallel to this third side. Perfect. And then I do have my yellow piece, both of my yellow pieces. And then this side gets split to x plus 5, but we do need to find this missing piece. And so that missing piece is going to be 36 minus 20, which is 16. So the only thing I'm using the 36 for is to get the 16, and then I'm done with it. So let's write that out. That would be 30 over x plus, 30 over x plus 5. That ratio is going to be the same as 20 over 16. And you could have done red over yellow equals red over yellow if you wanted to. But again, just be careful. This is going to be multiplied by x plus 5. And so I'm going to do 30 times 16. 30 times 16 is 480. And that's going to be equal to 20 times this whole thing, x plus 5. So just be careful whenever you work that. Okay, so what we end up getting when we cross multiply is 20x plus 100 equals 480. And then you subtract 100 from both sides, and you divide 380 by 20. And when you get that, you get x equals 19. Again, check yourself before you wreck yourself. 19 plus 5 would give me 24. And then the way that 24 relates to 30 is the same way as 16 relates to 20. And you can go backwards as well. 30 over 24. 30 over 24 is going to be 1 1/4, as well as 20 over 16 is also going to be 1 1/4. So you know you did it right. You can always check that math. So that is the triangle proportionality theorem. Sounds scary, but it's really not. Now let's look at, that's for triangles. So now we're looking at things that aren't necessarily triangles. We also have something called the parallel line proportionality. So no longer are we just looking at three-sided figures, we're looking at parallel lines. And here's what it says. If 3 or more lines are parallel to each other, if 3 or more parallel lines intersect 2 transversals, okay, this is interesting. So we need at least 3 or more parallel lines, which we do have here. Let's highlight them. These 3 are parallel, 3 or more it says. And you have 2 different transversals. So I have the blue transversal, and then I have the orange transversal. Then they cut off the transversals proportionally, meaning that this little piece, AC, the way that it relates to CE is going to be in the same ratio that BD relates to DF. We're not saying that those pieces are equal, we're saying that they are cut off proportionally. And so let's fill that in. This says that if AB is parallel to CD, which is also parallel to EF, and y'all, this could keep going, you could add more parallel lines. If all of those are parallel to each other, then we know that the way that AC relates to CE, AC over CE, is going to be equal to the ratio of BD over DF. So we can set up this proportion. So I'm going to do that again in colors, but I'm going to change these. Oh, goodness, undo. There we go. Okay, so the way that, we'll go blue, the way that blue relates to orange is going to be equal to the relationship of this blue to this orange. Okay. And so again, I'm going to use that parallel line almost like the fraction bar. This middle parallel line between them is going to be like the fraction bar. And then I'm going to use those little parallel symbols almost look like an equal symbol. So blue over orange equals blue over orange. Okay, so they give you this picture. If you're wondering where we're looking right now, we're all the way over here. And we're going to fill in these 3 boxes based on this picture. So they actually go ahead and do part of it for you. They say, okay, A over B, that's going to be equal to what over E? So you're just looking for the missing piece. A over B is equal to what over E? We've got these parallel lines. We actually have 4 this time, so they actually show you that math. And so that is going to be one of those green pieces. That green piece is going to be D, D over E. So we're missing that green piece in that one. So we're just filling in what they have already set up for us. Okay, they do that again, and they say, okay, well, B, blue, over what equals E, blue, over F. So I'm going to do that in a different color. I'm going to do that in orange. Okay. So what is the orange piece that we're missing? The orange piece that we're missing is C. C. Okay. Let's keep going. Now they go A, a green, over B plus C. So that's a blue plus what did I do that in orange? That's going to be equal to D, which is another green. And we want to do that exact same thing, but we want to stay on that same line. So that's going to be a blue plus an orange. So let's fill that in. What are those letters? That would be E plus F. So as long as you are consistent, you can set up these proportions. Okay. A over D, green over green. I like color coding. This just really helps me. Green over green is going to be equal to C, which is an orange, over what? The other orange piece on that line would be an F. Okay. Then they just reverse it and they go, okay, let's keep C over F. But let's go look at a different color. C over F is equal to what over E? Well, that's a blue, so that's top over bottom. That would be B. That would be a B. Okay. Then they do another addition thing, so they go C over F. Let's see where C and F are. C is orange. Okay. C is orange, and F is also orange. So then we have A plus B. That's this entire thing. So that's going to be D plus E. D plus E. So that was a green and a blue added together, and a green and a blue added together. So as long as you are consistent, you can set up all of these proportions just using the parallel line proportionality. All right, we can also solve for missing pieces. Not only can we set up proportions, we can also solve for missing pieces. So again, you have to have 3 or more parallel lines cutting off 2 transversals. Okay? So the relationship between blue and orange should be equal. So the ratio of 12 over 30 should be equal to 14 over x. And of course, we're just going to cross multiply. And when we cross multiply, we get x equals 35, which would make sense because that's big over small. Big over small, big over small. Okay. Again, we have 3 or more parallel lines being cut off by 2 different transversals. And so blue and blue, pink and pink. So the way that 27, pink / orange, I keep calling it different colors. Sorry, y'all. Pinkish orange is what we'll call it. Equals 18 over this missing piece right here. We need to find that. That's going to be 32 is that full amount. Minus the 18 gives me 14. So that's going to be over 14. You cross multiply and you end up getting x equals 5. X equals 5. No, it does not. X equals 21. I'm sorry, guys. Just retyped it in. X equals 21 right there. That makes sense, though, because this is going to be small to big, small to big. Okay? 21 over 27 and 14 over 18. So that should be 21. Okay, now when we get to this one, we've got our yellow parallel lines cutting off 2 different transversals. And this one has an expression there. So there's my pinky orangey color. And this one has an expression, so when I do 24 over 18, I need to set that equal to 3x plus 1 over 12. So I'm going to throw that 3x plus 1 in parentheses so that when I cross multiply, 24 times 12 is 288, and that's going to be equal to 18 times this whole thing, 3x plus 1. So that's going to be 288 equals 54x plus 18. And when you solve for x, you end up getting x equals 5. X is 5. Always go back, plug it in, and check yourself before you wreck yourself. 3 times 5 plus 1 would be 16. And the way that 16 over 12 is the same as 24 over 18 when you reduce them both. Okay, I see another expression popping up on this one. So we're actually just going to save time, we're actually just going to set this one up. And then you can do the math on your own. But we've got the blue pieces comparing to the pinky orangey pieces. And so that would be 2x plus 2 over 21 equals x plus 3 over 12. This is actually, it's going to be the distributive property twice. So I am going to set this up for you. 2x plus 2 equals 21 times x plus 3. You're going to have to distribute the 12 to both of these pieces, the 21 to both of these pieces, and if you do it right, you should get x equals 13. So come see me if you don't get that, and we can work on the distributive property skill. So we have done, so far, triangle proportionality theorem, parallel line proportionality, and last but not least, we're going to have a triangle angle bisector theorem. So remember that an angle bisector splits an angle in half. So obviously, since we're looking at a triangle, one of these 3 angles is going to be split in half by a ray or a segment. So it says if there's an angle bisector, which is going to be this blue thing right here, if there's an angle bisector in a triangle, then it divides the opposite side, meaning these 2 pieces. It divides the opposite side, I'm going to do that in pink, into 2 segments that are proportional to the other 2 sides of the triangle. So those 2 small amounts are going to be proportional to these yellow amounts, to the other 2 sides of the triangle. Okay? So then it just wants you to actually fill it in. If AD, that ray, bisects CAB, which it does, we have these little markings that show it does bisect it, then your relationship between A over B, so that would be, I kind of turn my head sideways when I look at this too. You could use that as the fraction bar and go B over D, full amount over full amount, yellow over yellow, equals pink over pink, A over C. I like to look at this like there's a fraction on the left side of this and there's a fraction on the right side of this. So yellow over pink equals yellow over pink. So B over A is going to be equal to D over C. B over A equals D over C. So you can kind of see that set up. Full amount over small amount on the left, full amount on the left over small amount on the left equals full amount on the right over small amount on the right. It would also work, though, if you did B over D, yellow over yellow equals A over C, pink over pink. As long as you are consistent, you will be fine. Okay, so where is my angle bisector here in this triangle? It's right here. It is an angle bisector. And so what I can do to make that match is I've got these two full amounts. 18 is the full amount on the left, on the right. 24 is the full amount on the left. And then here's my pinky orange color. This third side gets split. And so what we just said to do is just to keep it as a fraction on each side. So x over 24, orange over pink, equals 12 over 18, orange over pink. So of course you're just going to cross multiply. So 24 times 12. 24 times 12 is 288. And then you divide that by 18, and we get x equals 16. 16. So if I wanted to know what is that full amount in that triangle, you go 16 plus 12, which is 28. But it did not ask for that, so we're just going to keep going. Okay. So you always have to start with, do I have the thing that allows me to do the procedure? This is an angle bisector, so I am able to use this procedure. So that third side gets split into two pieces. Those two pieces are going to be in a ratio with these full pieces. And so that would be 4 over 6 should be equal to the relationship between 2x minus 12 and 3. So orange over yellow equals orange over yellow. Again, this is a distributive property problem. So 6 times 2x minus 12 equals 12. You would do the math on this one. You would get, let's see, let me make sure I've got this. Okay, so that'd be 12x minus 72 equals 12. You'd add 72 to both sides, and you end up getting x equals 7. X equals 7. Okay. All right, this next one's a little bit different. We still do have the angle bisector, so there it is. But we do need to go ahead and find this missing piece. And so when I switch to the colors, and I'm going to do orangey pink over this one, I'm missing one of those. So I'm going to do 14 minus 6. 14 minus 6 is going to give me 8 for this piece, because I do need to have that piece. Okay, and then my other full pieces, the full piece on the left is 12. Full piece on the right is 4x plus 4. And so then we're just going to set up our fraction. 12 over 6 equals 4x plus 4 over 8. That is the yellow over the pink. Again, you're just going to cross multiply. This is the problem where you have to use distributive property. Come see me if you need help on that, but you should end up getting x equals 3. Okay. All right. Here we go. Last one, we've got the angle bisectors here. So that is splitting this third side into two pink pieces. And the way that those pink pieces relate to these yellow pieces should be equal on both sides. So 10 over x equals 20 over, oh, this one's going to be tricky. We don't know this piece, and we don't know what this one is, the x. But I do know that if the full amount is 15, then this expression is going to be 15 minus x. So this expression is not 15, that's the full amount. It's going to be whatever x is subtracted from 15. So this one's probably the most difficult that you've seen so far. If that were 15 and 5, you would just do 15 minus 5 is 10. But since we don't know what it is, it's an x, and so you do 15 minus x. Okay? So again, put that in parentheses. That'd be 10 times 15 minus x, you distribute, equals 20x. You get 150 minus 10x equals 20x. So 150 equals 30x. So x should be equal to 5. Plug it in and make sure that that makes sense. This will be 5. This will be, oh goodness, this will be 5. This will be 15 minus 5, which is 10, which does in fact add up to 15. And 20 over 10 is 2 over 1. 10 over 5 is also 2 over 1. So here is your 8.4 homework. We've got triangles, parallel lines, setting up proportions, and actually solving them for missing pieces. So I hope you are having a fabulous day.